Hi, my name is Richard Thompson. I live in Sugarland and I made the group the Greatwood DIY Solar Forum. You're not going to be looking at my face the whole time. I'm going to show you a picture of my house and we'll look at that while I talk about the first topic. I've written up an outline and I'm kind of going to follow along that outline and hopefully I'll have some interesting pictures for you to see and that kind of stuff. So if you're interested in this group and you're interested in this video, then we'll talk about the benefits of solar first. So let's see. One of the benefits of solar is saving money. Another benefit of solar, of course, is you're using a renewable resource. You're not burning anything. You're not making CO2. You're not making more global warming gases and that kind of stuff. Typically, most of these components have a 25 or 30-year warranty on them. They degrade a little bit over time, but they don't really degrade very much. And you can see I have 3 panels on my roof right here. I've got a total of 8. I've actually got a really complicated roof, which is kind of a pain in the neck, and we'll talk about some of that stuff. Anyways, you probably don't need a whole lot of selling on the benefits of solar. So I'm going to jump into some terminology. So my intention is for you to be able to use the information that you get in my experience in dealing with Sugarland, the HOA and Centerpoint, and hopefully you'll be able to put solar on your roof also. I've done 2 systems. I've done this one here in Sugarland, and I've done one at my parents' house in Wimberley, Texas. That one is a really simple roof, much more ideal than my roof, and I have 18 panels there. I have 8 panels here. So let's go into some terminology first so I can describe what I have. The first term that we need to know is a watt, W-A-T-T, like a 60-watt light bulb. It takes 60 watts of power. And if you run a 60-watt light bulb for 1 hour, that is 60 watt hours. Your bill is in kilowatt hours. So 1,000 watt for 1 hour is a kilowatt hour. Panels are going to be rated in kilowatts. The system is going to be rated in kilowatts. It's going to produce in kilowatt hours, right? So if you, when you're looking at equipment, that's how it's going to be rated. We also get into volts. We also get into amps. We also get into AC and DC. Those really are not all that important to totally understand. Volts is how much work the electricity is capable of doing, kind of like pressure in a pipe. So your wall outlet is 120 volts. Your dryer plug you could think of as 240 volts. Those are both AC, alternating current. And I'm going to put up a little picture of alternating current. That means that it cycles 60 times per second in the United States and 50 times per second in Europe, but whatever. So it cycles back and forth as opposed to direct current. Direct current is what batteries use, and it's what your car uses. And if you have an electric car, it uses a battery and it uses DC power. It may convert it to AC at the last second, but you could think of AC as home electricity, DC are batteries. Now, the reason you need to understand that is solar panels put out DC. So you can't just take the solar panel and plug it into your house wall outlet because it produces DC, not AC. Another example of AC is right here. These monster power lines in the backyard. Those are AC, and they are, humongous amount of voltage. It steps down and then it comes into the house as 240. So what you need is you need solar panels. You need a way to convert the solar from DC to AC, and that is called an inverter. And what it does is it takes plus and minus constant direct current that the panels make, and it converts them into alternating current that your house needs. And you see in the little chart how the alternating current went up and down 60 times a second. The inverter or microinverter has to match that, because if it's out of phase, if it's going up when the other one's going down, it's going to try to actually cancel it out. So for it to help, you need it running at the same frequency and the same phase and all that. None of that's really all that important. All you have to know is you need one piece to get from the DC that the panels put out into AC that your house can use. And that piece is either an inverter or it's a microinverter. So I have what are called microinverters, and I think they're the best thing. I actually have 8 panels and I have 8 microinverters because there's going to be one that sits underneath each panel. And you can't see them because they're hidden by the panel. They are a kind of a chunky electric box with some cables. The nice thing about it is technology has advanced so much in this department that it's all plug and play. It is as easy as plugging in, I don't know, an HDMI cable into your DVD player or into your TV, whatever. The other thing is it's very safe, and we'll talk about the safety aspect of it. So there's 2 main ways that you have for running an inverter. There's one called a string inverter, which is made by Solar Edge, and it's made by ABB, and it's made by SMA. I think there's a few different companies that make them. I don't use those. The big problem with a string inverter is you hook all the panels together in 2 strings. There's an A string and there's a B string. So if you had 8 panels, you would put 4 of them on A and you'd put 4 of them on B. And what they do is those 4 panels would go to one channel and the other 4 panels would go to a second channel. And that's all fine. The problem is shading. And if on a string inverter, if you have 8 panels and one of them gets a certain amount of shade, it affects that whole string. So if one of them is shaded, it's like all 4 of them were shaded. The other 4 are unaffected. But so what ends up happening is if you have shading problems, or if you have a complicated roof like mine, string inverters are going to be trouble. I have 2 panels that face the east. I have 3 that face south. Those are the ones we're looking at. And I have 3 that face the west. So what ends up happening is the 2 panels that face the east, they start producing electricity early in the morning, earlier than the others. And they start producing electricity when the sun is coming up in the east. You see how I've got 3 panels on my roof here. 1, 2, 3. And you can see my chimney is casting a shadow kind of that direction. Right now, it is 4:30, and it's February 4th, I believe. So we'll go back and we'll look at the other 2 panels. So on my system, my 2 panels that face east, they come on first. The ones that face south come on for most of the day. The ones that face west, they come on last. But when the west panels are doing their job, the east panels have already kind of cashed it in for the day. So that brings us to orientation. You want to have as many panels facing south as you can. We'll look at this face here. You can kind of see I've got 2 panels on the east side. And so what ends up happening is the most efficient direction when you're in the northern hemisphere is you want your panels facing south. If south isn't possible, then you want them facing southwest. If southwest is not possible, then you probably want them facing west. And if west is not possible, then you want them facing southeast, and then east is your last. And beyond that, they can face north. North-facing panels in the northern hemisphere are not going to do a good job. So, easiest way to figure out your compass headings, you can either pull out a compass, or you can load one on your phone, or you can just go into Google Maps, find your house, and make sure the north arrow is pointing up, and you can see your roof, and you can see which direction your roof is facing. So for me, I actually ended up building a 3D model of my house in a program called Google SketchUp, and I was able to predict what the sun would look like. But you can just go out and you just take a picture of your roof in the morning and at noon and in the afternoon, and you can look for shadows. If you have a complicated roof, you're going to want to use microinverters. If you have shadows on any panels, you're going to want to use microinverters. If you're concerned about safety or reliability, you're going to want to use microinverters. The ones that I like are made by the world leader in them, which is a company called Enphase in California. They have factories in China and Mexico and I think the United States. Anyways, they make the best ones in the world, and they're incredible in what they do. From a safety standpoint, they are awesome. And the reason I say that is a solar panel, if you lay it out in your backyard, let's just say you just left it on the grass, it's got two cables that stick out of it. Unless you stuck paper clips in them or you stuck them both in your mouth, you're not going to get shocked by those things. Now, those are outputting DC and on the order of maybe 50 volts DC, which would, I'm sure, be enough to hurt you if you somehow, I don't know, cut into those wires or did something really dumb. When you plug the microinverter into it, or when you plug them into the microinverter, they just have connectors and they just snap right in. And their special connectors are made by a company called Amphenol, and they just snap right into the microinverter. And there's a plus and a minus, and they only go in one way. So that's really cool, really easy. And once you've done that, you're not going to get anything out of them until they sense the grid. And remember that they are inverters. They change the electricity from DC, which would charge a battery, into AC. And they put out 240 volts AC, which is, what's your double pole breaker, like your electric stove and your electric dryer and a car charger or whatever. They use 2-pole breakers and they're 240. That's kind of scary, except microinverters, as soon as they sense that the grid is not there, they shut off immediately. They have to have the grid to work because they synchronize with the grid. So they detect where the grid is in its up and down cycle, and they match that. And so within a millisecond of the grid disappearing, they shut off. So if you take the panel and you plug it into the microinverter, it basically is inert until you flip on your breaker and you're basically done with the system. If you have the other kind, the string inverter with the A and B strings and all that, you've actually got DC voltage and cables running across your roof. And those can be dangerous. Some of those voltages can be lethal. You have to label them specially. And when you hear about solar panels catching fire at Walmart or whatever on their roof, it's that style. It's string inverters, not microinverters. The microinverters have a really, really low failure rate. And they're an amazing little piece. They have a 25-year warranty. They do soft start and other things that are required by California. And what soft start means is if the power goes out, when the power comes back on, you're not going to have 600 solar panels all dumping electricity at the exact same instant. They can be staged so that they come on, half a second, 2 seconds, whatever, apart from each other. And I think they can also maybe be shut down remotely and that kind of stuff. You don't have to worry about any of that. Know that they are UL Underwriter Laboratory listed components, and CenterPoint, who is our grid provider, they're going to love that you use them because they know what they are and they are safe and they are UL rated to do what we need them to do here in Texas. So we'll talk real quick about the HOA. The HOA rules say that the panel needs to follow the roof line of the house. So if the tilt of the panels, the rule of thumb is if you're at a latitude of 25 degrees, then your panels ought to be tilted about 25 degrees. The thing is, you're going to put the panels on your roof, and they're going to be set at whatever the tilt of your roof is, and you'll just have to live with it. And you have to look at your roof and figure out what can go where and how they're shaded. If you're using microinverters, which we all will be, then if you have a chimney that shades part of a panel, that one panel will decrease its output a little bit because of the shading, and it won't affect any of the other panels, which is really nice. The other thing is there's a law in Texas, and that law says that the HOA cannot tell you that you can't put solar panels on the front of your house, or they can't tell you what side to put them on if they cost you more than 10% efficiency. And I can show you how to do the calculation if you want to, and you can probably show that having panels on the back of your house instead of the front, if that's what you wanted or whatever, if the front of your house faces south and you had a perfect roof for it, they can't deny that to you if you can show that you take a 10% efficiency hit. And if that's the case, then you can use a program called PV Watts, which we'll talk about, to predict the performance of your solar panels. And PV Watts is a free program. It's put out by the National Renewable Energy Laboratory in Colorado, and we'll be going through that. But in my experience, the HOA was very reasonable about it. I sent them some photographs. I sent them some Google SketchUp pictures. I don't know that really was required, and they approved my solar panels. They were the easiest entity to deal with. Sugar Land City, to get a permit, a building permit, they were kind of a pain. CenterPoint, they were kind of a pain, and they literally took, I believe it was 3 months to approve my permit. So you can put that in once you get your other permits done. CenterPoint's not going to deny you, I don't believe, but it just takes them a while because you're becoming a competitor for them, and they don't mind dragging their heels a little bit before they allow you permission to operate, which is called the PTO. So CenterPoint eventually will give you a letter that'll give you a permission to operate, and when you get that letter, then you're allowed to turn your system on. So when you have got your plan for your solar, you want to go ahead and submit your paperwork to CenterPoint as soon as you can, just because it's going to take a while. That's going to be it for this first part of the video. I'm going to do a little bit of editing of I'm going to put the alternating current on there, and then the next thing we're going to talk about is the duct curve.